I hope you can hear me. And I hope this time I don't run out of battery again in my microphone, or that the lights don't go off all of a sudden. Welcome to another live stream where I'm continuing working on a machine learning project. I'm building a machine learning model for image classification for a Raspberry Pi camera. So this was the plan for yesterday's live stream, and I was able to complete this step. I was able to evaluate the Tensorflow Lite Model accuracy. It didn't really go according to plan because I was hoping to have a fairly good starting point of accuracy. I was expecting the accuracy of the TensorFlow Lite model to be lower than the full TensorFlow Lite model, but it turns out that it's much worse. So I think because it's so much worse, right? So the accuracy of the model I trained with TensorFlow using my own data set was 95%. This was the accuracy on the validation data set. For me, that's already very good. I might be able to get better results, but I decided to stop at that and then continue with the project. Okay, so for the TensorFlow Lite model, I'm getting 40-something% accuracy. And because it's so much lower, right, I'm really hoping that was it was because of some silly mistake I made. I probably, one of the things I was checking yesterday was whether I forgot to normalize the image. When you're dealing with tensors and TensorFlow, that's why they call it TensorFlow, by the way, you normally have to normalize an image. And when I say normalize the image, it means that all the numbers, all the different pixels, they need to be, instead of being between 0 and 255, they need to be between 0 and 1. Okay, so that's my hope. Anyway, so I've just run the notebook on Kaggle. It's still running, actually. I just want to waste less time to make sure that I'm at the same point as I was yesterday. Okay, so if we have any time, then we'll try to complete. Well, this is already done in a way because I've already compared both. But I can do a more, once I eliminate the chance that I've made some silly mistake, I will do a proper comparison. But I would say this is already kind of done initially. But let's leave it like that. Then I did create a new version of the dataset I'm using. I added an extra image class of nothing, basically. The idea is that I want to identify a cat, either a cat or a bird or a fox. I don't get dogs in my garden, so I don't have to worry about that. So, but then I added the class called just nothing. It's just an empty garden. But I don't know if I need it because I think I can live without it. So, but I'll be curious to see what the results are. And then if we have enough time, we'll discuss the next steps in the Raspberry Pi project, in this machine learning project. Right. Okay, so it seems we have some people on the stream. If you have any questions, let me know, and I will try to answer any questions that come up. Yeah? All right. It should be fun live stream because I'll be coding and trying to fix problems. This is running. So it's actually training the model on Kaggle. It's already in epoch 35, so it should be finished fairly soon. I hope my microphone doesn't run out of battery again. I have some suspicions on what the problem might be. It's finished. The main part. It's now running. It's now running the Tensorflow Lite section, which is good. And this is where I left off yesterday. So it's creating two types of TensorFlow models. One is they call it the floating point TensorFlow Lite model, and the other one is the full integer quantized model. It's doing the evaluation right now, I think. Is it? No, it's still here. Where is it? Oh, it's still doing this. It's still training. Okay. Okay, so now it's doing the evaluation of the model. And I'm hoping that if I'm lucky, it's all going to work fine. And yesterday it was just bad luck. Okay, no, it's not bad luck. Okay, so the model accuracy for the TensorFlow Lite is 41%. I thought it was 45, it's actually even worse than that. It's 41%. And then we've used the full validation data set, 247 samples. Okay, now I need to go and have a look at the code and see what I might have. Maybe I made a mistake, so I'm just hoping for that. So, because I know, so I'm running the model here. TF Lite. So let's see. So the images are here. Okay, and we have okay, I added this here yesterday. And then we have, what's this input scale? Input scale. Oh, I see. This is only used if we, using like integers for the inputs. Okay. They're coming from here. I don't really have to worry about that for now. It's doing this here. I don't know if I did that myself yesterday. Test image. I'm just going to try. Just figure out if there is any silly mistake. So I'm going to comment out this line. I'm probably going to get some error. Okay. The error is because I still need this variable. I'll run this. Okay, so now it still somehow gives me a result. And now it's actually predicting the same as the ground truth. Sometimes it's something as silly as that you normalize something when you don't have to normalize because it's already normalized. I will confirm that in a second, but I just want to run this a bit more just to see if it could have been just luck. So we are running the evaluation again. And if it makes any difference, then I will just, oh, I see. It's much better now. Okay, so it was what I suspected, right? That, okay, this is lower than what the actual Tensorflow model can do, but this is acceptable already. But I will try to improve on it. But first, before I go any further, I just want to check. I commented out that line of code. And to be honest, that was just me guessing. And since it worked, so I can just confirm that those numbers already are between 0 and 1. I was trying to divide it again, and that's why. Where is the normalization? Normalization. Search is not very good. Okay, so this was the line I commented out, and I can try and do a print of the test image. print max. No need to run. Need to run this. Okay. Not very helpful, is it? Only zeros. So it has other values other than 0. Okay. So maybe there is not here, right? Let's see what type it is already. So type. Missing a bracket. The numpy and the array. And dimensional array. Anyway, it's working. So the only other thing I wanted to do, okay, so the accuracy is now, it's not as bad as before. So now we have 91% accuracy on the Tensorflow Lite model. I wanted to try also the fully quantized model, which has been compressed even further than this Tensorflow Lite model. And everything, model type, I don't know if model type is equal to float, but I'll just run both. Probably want to disable all that print statement. So let me just take it out. Sure, I run this first. Now I'm going to run the evaluation for both Tensorflow Lite models. And I should see hopefully similar accuracy between the two. So first one is 91%, which we already run before. And the second one, we'll find out in a second. So this is the type of model, the fully quantized model, which is the second model, 16 by times 8. This is the kind of model that can run on a TPU, on an edge TPU, because it only has numbers, right? it only has integers. It doesn't have floating point numbers, and the TPU is only like prepared to deal with models that have integers. I have to wait. It's a bit slower. Okay. Oh, this is surprising. So it's not floating. The second one is much. So first one is 91%, and the second one is 94%, which doesn't make a lot of sense to me. Of course, I welcome this result. So I need to have a look at the code. First of all, I'm surprised it says float model. So I'm going to go and open a Google Colab, which has the original Tensorflow Lite tutorial, which I followed the last time. Post training. Okay, I still have the link here, which is nice. So in this tutorial, which I followed, it uses the MNIST dataset, which is a dataset of handwritten digits, and it shows you how you can train and model and convert it to TensorFlow Lite. So the question I have in my mind is, how many values did we use? If I review I have a method as well, which is to get a representative data set. Maybe that's not actually taking enough values from here. It's only doing 32, I think. Find out, right? So this method is actually used to find out what are the highs and the lows. So when we do the conversion of the model to, for example, to do full quantization, to make everything an integer, because we are actually compressing the model, right? So we are converting a model from floating points for the activations and weights into integers, right, of 16 bits and 8 bits. So the algorithm actually needs to know what's it needs to have like a good estimate of what is the highest and the lowest value for those weights and for those activations. So that's why they basically ask you to write this method, which gives a representative data set, and it will use this to basically, for each item in your data set, in the representative data set, it will kind of call the inferencing code, and then it will use the values. I guess it will find like the highest weight and the lowest weight and work in that way, right? I think this one is quite poor. I'm only getting like 100. No, not 100, 32. So maybe I can improve the results if I make my representative data set bigger, right? Okay, but to be honest, I'm quite happy already. Having 94% is a really good achievement. And you can see here they've got 95%, but I think they started at the, let's see, what's the original evaluation? So the original model is 95% as well, accuracy. On the validation data set. And at the end, they show that they can also achieve 95%. They haven't lost any accuracy. Interpreter 1618. Oh. Yeah, I had to rewrite this method yesterday. Add batch dimension. I'm just, they look so different. It's the same. It almost feels like I'm not looking at the same code because I. Oh. I think I'm looking at some different Google Colab than what I was looking at yesterday. Ah. Yeah, I think I was looking at a different notebook. This is why I was confused. This is probably older. Yeah, this is newer. But then I already wrote my code based on the older code. Okay. I'm fine. I'm not going to recreate it again. So this is going to be only for visualization, right? So okay. So this is just basically a label. Quantized. Yeah, I'm still not very happy with this data, with the results. So we have okay. So I need to try and use this. Just going to do this experiment. So I'm going to improve this method here. I'm going to add another code block here so I can swap between the two. Okay. For version 1, this will be version 2. Okay. What I'll do, basically this is just going to force it to go through the whole data set. See. Let's see if this works. Now I'm going to comment out this block. We're going to run this model again from the beginning. I'm just hoping, because by forcing the conversion process to go through the whole of the validation data set, I'm hoping that if it allows us to have better accuracy. So we don't lose as much accuracy as what we had before. Already cool. Oh, I see. I think this is only used for generating the fully quantized model. Because this is where we've added some extra parameters here, the activations in 16 int 8. You know, we add this method, it's only used for that one. So there's no It's a bit weird. Why would the fully quantized model have better accuracy. We just generated another model, another version of the fully quantized model. Well, we're going to run the evaluation again and see what happens. So run after. Oh. It's actually not the quantized model, this one. This is the float. Just the label. That's the only thing it affects. For some reason, it's taking a bit of time to run this one. Unless it's running something else first. It's queued. So something else was running. Okay. So we're going to do the evaluation again. The float model accuracy is 91%. So the quantized model is a lot slower, but that's because it's not running on a TPU. It's a big drop, actually. So no quantization. That's the default option. And this one has quantization for the weights and fixed parameters. And then if we want to quantize things that are variable, so into then we have to create a representative data set. So right. Yeah, I think I might have to put this question to the Tensorflow team, just to understand what could be wrong. And learn from it. But I think yeah. I don't understand. Best label. So, fox. Wait, pretty the cat. Oh, okay. Yeah, it's already doing that. Right, so what's going on? So there's a pre-processing. I think MobileNet is actually not it's not 0 to 1. It's minus 1 to 1. That's why there's probably a difference. So I need to normalize the images in the same way, right? So minus 120. That's for learning. That option here. I think it's already doing that. Okay, I understand now. It's already doing this because it's part of the model. So that's why I don't need to do the normalization. But there's still the case, it is still the case that the Tensorflow Lite model is getting worse results. This one is getting bad results. Okay, I don't know why, but the 91% it's acceptable for now. Right. It's the diff. Yeah. printing it. Boom. Full 32. So a small loss of accuracy is expected, but 5% I think is too much. But actually, it's quite expected. So the 0719 is the original accuracy of the model, and then after after post-training quantization is 0.63. I need to put this into a problem statement and go into the TensorFlow website and ask this question. I'll probably do that on a next live stream. But I think for now, I have good enough results. I'll probably use the fully quantized model anyway, because I want to have as much accuracy as possible. And I need to evaluate this against the test data set, which I will load separately. Okay, so let me just load that test data set. That'll be the last thing I do here. So we have going to load this test data set. Okay. Need to run this again. So test data set, data set. To run this, should copy the test data set to where I want it to be. Let me just get the reference to the directory. So this is data set that hasn't been seen before at all. I haven't even run this test data set yet with the full TensorFlow model. I'll do it. So let's take this out. So then equal to Okay, and then we take this validation split, and the seed is no longer needed. Batch size we can keep the same. Batch size, image size the same. Okay, we can run this. Okay, we have quite a lot of test data. I probably want to limit this. It's a lot of test data. So I'm going to change the number of samples to 100. I'm going to delete the directory, the contents of the directory, so that nothing is left over. This again. Samples. That's correct, right? Number samples. Just put this back. Data set. Okay, you can see 100 birds, 100 cats, and 100 foxes. Then we can load this again. Why is it reading from? Not sure what's going on. Oh, I see what's going on. Okay. This is why maybe it was so big in the first place. Because I forgot to change the directory name. Okay, so now it's more or less normal. Data set. Okay. So I'll pass this as an argument instead of just passing it like I was passing it. Okay, so now I just create. Maybe I can move this down. dataset. Let's see. Position argument functions. I think put this before the model type. And now just need soaked arguments. Should be able to get no. So I have now, so I'm now evaluating the model against the test data set. I'm hoping the output now. Let's see. It's the first time I even have any. I haven't run anything against this data set before, so this is going to be new. These are just images from my garden that I didn't use for training or for validation. So these are completely new. Hope the same order applies to. Just have to be careful. Assuming it's the same order, but actually just make sure class. So the class names, I'm assuming that they are going to be in the same order, but I can't take a risk. I don't want to take a risk on that. So I just want to remember what. Okay, let's see. Yeah, this is the one. Okay. No, for this. For the next time to run. Let's see how, what there was 50%. I need to remove some of this debug. Good. Print. I'm going to try and call this evaluate, also to see how it compares to the full model. I haven't actually, I don't even know if, I think I have something wrong in my code. Looks very horrible actually. So it's strange because, okay, so the test data set is doing a lot worse than yeah, this is something I need to understand. So I've added a test data set and it's doing much worse than I expected. And I don't know why. So I need to export these images a bit. Okay. Yeah, so interesting, right? That the test data set, which is, in my opinion, should be very similar to the validation data set. It didn't actually. Render path. Let's see. Okay, let's see. That's a fox. So okay. Right, so I think I'm going to finish here. So I need to do a bit more work on the model, unfortunately, because when I apply the test data set, which is supposed to be very similar to the validation data set, the accuracy drops a lot. So I can't just ignore it. I need to understand why this is happening, because yeah, I mean, 35% accuracy is not good enough. So I might be missing something from my code. Just like I was missing at the start of this session, I figured out that I was also, I was normalizing an image when I didn't have to. So I need to go back and do some extra work on this notebook. Thank you so much for joining this live stream. So I'm going to finish now. I'll see you again soon.